For our next session, I want to welcome Evan Pilecki. He's the product manager of cryptographic key management at Thales Trusted Cyber Technologies. He's going to join us to discuss their top 5 best practices when it comes to zero trust. Welcome, Evan.
Thank you. Thank you all for having me this morning. So I'll be giving you a top 5 tips on implementing zero trust in your environment today. For those not familiar with Thales Trusted Cyber Technologies, we are a business area of Thales Defense and Security Incorporated, or TDSI. You might be familiar with them if you're in the DoD space for their radio, SATCOM, and other systems that they build. And we fall under then the Thales Global brand. So we're headquartered, Thales TCT is headquartered up 95 in Abingdon, Maryland. And for over 40 years now, we've been a provider of cybersecurity solutions into the US federal government. So tip number 1 is going to be focus on the data. I think we've heard this mantra a little bit this morning already. And as I go through this talk, I'm going to be referencing both the CISA model and the DoD Zero Trust Reference Architecture, both the 2.0 versions. So NIST made it very clear in the CISA 2.0 model that the focus is on preventing unauthorized access to the data, and they want everyone to take a data-centric approach. You can see they have, you have the 5 pillars all lined up there and all leading toward the data, right? So the central question of zero trust is who is accessing the data and what data are they trying to access? And can we give them access to the data at that time, right? And so all of the checks that go through all the other pillars are meant to invoke barriers so that checks happen before an authorized individual or non-authorized individual attempts to make contact with data and the data is served up to them. The DoD model is much more explicit than even the CISA model about the centrality of data within the architecture. They have it graphically represented with data at the center and the other pillars surrounded, and explicitly talks about how the other pillars are meant to work together in order to protect the data. So zero trust is really about the focus on the data itself and that being the critical resource you're trying to protect through building up the architecture of the network. And we can illustrate this a little if we sort of take a step back and look at a basic transaction that might happen over a network. So here we have Jan. She's going to log into her computer and access a web application over her browser to get some customer data back. And when we talk through each of the pillars, there are some questions that we're going to ask. The first is, there we go, how do we validate Jan's identity? This is the first question that we ask in, that access transaction. Is Jan trying to access, or does Jan have to authenticate with multi-factor authentication? Is the certificate authority that is backing the enterprise PKI rooted in a hardware security module? So we can provide assurances that Jan isn't trying to access the network with a falsified certificate. Next, we look at her device. And how do we ensure the integrity of that laptop? Is she connecting to the network with a personal device? Is that allowed on the enterprise? Does the organization have a bring your own device policy or not? If not, she shouldn't be allowed to connect with that device. Is she connecting with an organization provided laptop? And does that laptop itself report its compliance with current patching and configuration policies? Then she's obviously connecting over some network. Is she working on the organization's network? Is she plugged in at the office somewhere? And is that network properly segmented from other departments so she can't access their data and they can't access hers? Or is she connecting remotely, right? And so she's connecting over the open internet. Are the servers that she's connecting to providing an authenticated TLS session to her? Zero Trust is trying to move folks away from using a VPN connection and working directly with applications served over the internet. And that means that connections to those applications themselves need to be protected by some manner over the network, like TLS. Then there's the application itself, and how is that application secured? Does it require another moment of authentication, through a federated single sign-on event? Does it re-authenticate Jan? She's obviously logged into her laptop, but is the application itself checking the authentication by Jan to get into the system? Is the data that the application is using itself encrypted and protected while that data is in use? And what is the supply chain and DevSecOps process of the application? Is it a government application, so all that's being done in-house, or is it a commercial application where you really need to dig into the supply chain and understand sort of how the vendor is protecting you from those supply chain attacks? And then lastly is the data itself, right? We talk about how this is a data-centric approach, and how is that data protected? As a baseline, is it encrypted? do you have additional moments of authentication to the data itself, right? So we can authenticate at each of these pillars, right? So Jana's going to introduce her identity at the beginning, and each of the following pillars can do another check against her identity, including at the data lever itself. All right, so then we're just going to move to the second tip here. So the second tip is assess current capabilities. So this really talks about, I'm going to talk about this in two different ways. The first is everyone here has a lot of product deployed into your environment, and when you're looking to go through the Zero Trust maturity models, there's an understanding, right, that that whole process is a sort of a ratcheting up of the sophistication of different technologies. But you have a lot of technology that exists on your network already. So what we really want to focus here is what products do you have and what sort of potential have you not tapped into those products, and really getting a baseline understanding of what your products that are currently deployed can do, right? I assume that many folks here have some sort of smart card, multi-factor authentication on their network widely deployed, be it CAC or PIV. And so you have that deployment now, and you have all the underlying products that support that authentication. Can those products for you, without having to go do additional procurements, support that ratcheting up in the Zero Trust maturity model and provide you, you're capable today, it's deployed today, is it capable for tomorrow? The other side of that coin is, okay, so I'm not necessarily looking to expand the depth of the maturity of a particular product, but I have a product that can do a lot, but I'm only right now using it for a little. Right, so this is looking at different capabilities within the DoD reference architecture of data and analytics, and so these are some examples of those capabilities pulled out of that architecture. And say I have an enterprise key management and data security platform, and right now I'm using it to do transparent encryption into my on-premises data storage, and then maybe doing some centralized key management of my cloud instances as part of my data access control solution. But I go back and I work with the vendor, and that product, through some additional licensing I could procure, will let me do data tagging and labeling. And then, I work with that vendor some more, and maybe I want to do some, behavioral analytics and have this other product that I've already deployed that does my analytics for me, and I discover that my enterprise key management and data security platform can integrate with that analytics tool, and allows me to feed it, all the behavioral analytics that are coming from my transparent encryption transactions. I can feed that into the analytic tool, and now I have a more robust solution because I'm able to integrate those two products and provide the analytics, user heuristics based upon how they're accessing the data that is encrypted through my transparent encryption solution. And then maybe I also learned that right now under my ATO, I'm running a particular version of the product, but if I upgrade the product, I gain access to new functionality that hits additional capabilities, like being able to, say, add dynamic policy configurations to my encryption. Our third tip here is talking about supply chain. So we really want to focus on, especially when we're bringing in commercial off-the-shelf product into government networks, focus on the provenance of those commercial products. Do you know what that provenance is? CISA in its 2.0 model added references to NIST's asset and supply chain risk management framework, and DoD specifically calls out that to build a more robust and mature zero trust implementation, you should really be focusing on the secure supply chain of software. And so we have all these bills of material. I won't quiz you all. Sometimes when I do this talk, I like to throw hands and be like, hey, what's this? We're not going to do that today. So hardware bill of materials, I'm sure everyone is aware, is if I have a server appliance, I go through, and a hardware bill of materials is just a list of the physical components that make up that server. A software bill of materials is currently working its way through the federal requirements as an insistence on vendors to provide a software bill of materials for all of their applications. And this is similar to a hardware bill of materials where with an application, it's a list of all of the open source, third-party, and first-party software components that make up that application. And what that allows you to do is if a CVE comes out against a particular open source project, it allows you as the user to quickly cross-reference that CVE against all applications that are currently running, and if any of them are using the particular affected version of the open source project that is called out in the CVE. And this allows you then to go back to the vendor and say, hey, this is this is popping as potentially in conflict with the CVE, can you provide me a mitigation? And the vendor has the opportunity then to say, based upon the way that we've implemented that open source, you're not vulnerable, you're good to go, or here's the mitigation that we're going to put in place, here's the software update, here's the patching that needs to occur in order to get you clear from that CVE. And then a cryptographic bill of materials is a little different, and it's relatively new. It's a little newer than software bill of materials. NIST has been talking about it a lot in terms of the PQC transition, the post-quantum cryptography transition, and this being a valuable tool there. So a cryptographic bill of materials goes through, say an application, and it lists out not what software components are being used, but what cryptographic algorithms and products are being produced. So your certificates and keys that the application is making, and what algorithms they're utilizing to do that. And as part of the PQC transition, this allows you to easily identify, okay, here's my applications. They're currently using, RSA or ECDSA. Those all need to be replaced per CNSA 2.0. And so now I know which applications to target and isolate, and I go back to those vendors and say, okay, when are you giving me an update that makes me compliant with post-quantum cryptography? It also allows you, as algorithms are, exposed to malicious actors and algorithms themselves become vulnerable, similar to an SBOM, it gives you a great then reference to say, okay, single DES keys have been broken. What are all my applications that are using single DES that need to go up and have updated? And then we can talk about, okay, what are the vendors doing for me to protect me from supply chain attacks? Axios reported a couple weeks ago that, in looking at the first 9 months of 2022 compared to the first 9 months of 23, they worked with a security firm to do an analysis, and there was a 28% increase in the number of malicious packages that were hosted across 3 major open source repositories. These are the open source repositories that your vendors are going to pull in code that is then being put into product being sold into government networks. So that's a big surface area and vectors of attack. And other open source reporting is showing that nation state actors and criminal organizations are increasingly relying on supply chain attacks as the vector of attack into networks. So it's imperative that you understand what are your vendors doing for you to protect you from supply chain attacks. And so we at Thales TCT, we have a process that we call the Trusted Technology Import. I'm not going to walk you through it. You can see it's a multi-step process. We, as part of that process, convene a cross-functional panel, goes through this process. So it's not just an engineering effort. It's an engineering, product management, operations. So it's a lot of different people across the organization that go through this process together to make sure that we're doing all these checks to protect and ensure that the products that we push out are, the risk is mitigated as much as possible from, the external components that we're bringing into our product. So we had formalized this product since 2016. We've been using it, and CFIUS thought it was such a great process that they actually put it into our national security agreement with CFIUS that we are required then to use this process. We were originally doing it without that requirement, but CFIUS looked at it and they were so impressed with what we were doing that they made it part of our requirements to ensure that it continued into the future. So we do this against all sorts of things coming into our product. We do it from open source, any third party that's not necessarily open source. Commercial hardware that we're bringing into our product goes through this process, as well as anything we're bringing in from the global Thales commercial side of the company that we're bringing over to the government side. We also run it through this process. Tip number 4 is leverage vendor expertise. So, no one should be going through this alone, right? Zero Trust is a big effort, and we don't want the government customers to be going through it alone and trying to figure everything out. So you really should be leveraging your vendors. And we look at this in 2 different ways. One, you have the vendors who are specialized in a particular product area. Here I'm going to pick on the storage solution vendors, right? And they're going to provide you the expertise that when you're trying to go through, again, that maturity model and ratchet up the sophistication of your solutions, they're going to be the ones that can provide you sort of that in-depth, here's the maximum capabilities that we can provide you within our solution, or here are the integrations that you need to tack on in order to reach whatever level of maturity you're going for. And there's also then the the other vendors who maybe have a broader touch. So there are vendors and system integrators would fall into this category where we have a breadth of experience across multiple pillars. And what this does is provide you a way to unify your solutions, right? Especially looking at the DoD reference architecture, that talks about how all of the other pillars are meant to work together to support, protecting the data. The idea of, having and working with vendors and system integrators as your trusted advisors who have that breadth of experience allows you to unify your solution and identify, what components do I have working in my network now? And I can work with a vendor with a wide breadth of experience who has a large number of integration partners then tied in and say, how can we build a great architecture where it makes all of my pieces sort of work together to build a unified solution? This also then gains you access to sort of post-procurement support, right? So say I'm working with one of these vendors, and right now I just need an identity solution built now. But I know that this vendor has offerings across different pillars. Post-procurement, now I have that relationship built with them, and I can get after, right now working on identity, but know in the future that they will support me into expanding out to the other pillars and building up a unified solution over time. And my last tip for you, as I think has been said already this morning, but really focus on mature over time. This is, zero trust is not a quarter-mile sprint. It is a mountain climb. There's the graphic, which I stole from CISA. It's a great graphic. And it's really focusing on making sure that you take a breath and you have a plan and not trying to race toward reaching that optimum phase, right? You're not going to do it. It's really focusing on taking that sort of data-centric approach and focusing in on, what the data is, what is the critical data I am trying to protect, what current capabilities do I have so that I can sort of plan accordingly and know where I need to place my procurements in the future, what can I work toward now because I have those untapped capabilities already in-house. Understand the secure supply chain, so I understand which vendors are the best vendors to work with when I want to go and make those procurements that I need to make in the future. And then, working with those vendors and my system integrator so that I have a unified plan going forward and just doing this over time and iteratively. And thank you all for your time. We have a table over here. We would welcome you to further this conversation later. Thank you.